Exponential integration. Yan. Exponential integration. Exponential integration formulas. So let u be equal to f of x. Assume this is a differentiable function. And number one, the integral of a to the u du is equal to a to the u over ln a plus c. Where here, where a is positive but not equal to negative, not equal to 1. Okay? So again, what is a here, which is a constant that is positive but not equal to 1. And then a special case, if a happens to be e, so you will have integral of e to the u. If a happens to be e, so this formula now becomes integral of e to the u du, and that is equal to e to the u. So e to the u, but what is ln e? Because a is e, but ln e is 1, so we don't write that anymore. Okay? Then plus e. So here e is approximately, it is a constant approximately equal to 2.71828. So we have two formulas for exponential functions, no? Integration leading to exponential functions. Now, take note here that in the integral, yan. So again, in the integral, yan, integral of, let's say, a to the u, yan, du. Let's take the general form of it, because e to the u is just its special case. Now, in this integral, we call a, this is a constant. This is a constant, no? It is the base, which is a constant. It is base, which is what? Which is a constant. Okay? Of course, different from what? So it is a constant greater than 0, but of course, not equal to 1. And then u here is the power function, the exponent, no? So this is the exponent. So that is the exponent, yan, of the base. Yan. And it is a function, which is a function, yan, other than a constant, no? So meaning u is really a function, no? Yan. And then a to the u is it is a power. Yan. Yan. Different from what? Different from a which is actually not a constant, yung a to the u. It is a power function. It is a power function different from a constant. And finally, du here is the differential of the exponent, no? Meaning of this u. Differential of u. Yeah. Of the exponent u. Okay? If all of these things are satisfied, these requirements, then this integral is equal to, again, a to the u over ln a plus c. But remember, a is greater than 0, but not equal to 1. Is that clear, guys? And so let's apply that in evaluating integrals. Okay, this formula. Let us have the following exercises. Evaluate. Yan. The given integral. The given integral. Number 1. So integral of 2 to the x to the 4th, then x cubed dx. Now, if you're going to look at the integrand to x to the 4th x cubed, there are two powers, no? One is 2x to the 4th, and then the other one is x cubed. But if you are going to look at x to the 4th, x cubed is possible to be its derivative, no? So, it means what we are going to consider as power is the 2 to the x to the 4th. And since this is constant, the base, and the exponent is a function, then this is exponential integration. Huh? So let's check. So what is our u here, guys? X to the 4th. What is our a? Our a is positive what? Guys, positive 2, no? And then, what is du? Guys, what is du? For x cubed dx. Looking at the integral, now, in the integrand, together with the dx, so notice that our du is not yet complete. So, this x cubed is what? Has a missing factor to be du, na? What is that missing factor? 4. So we have to supply that so that this will take the form of a to the u du. Okay? So let's apply, what do you want? Simple substitution or correction factor? If you're going to have correction factor, then this can be written integral of 2 to the x to the 4th times, we have x cubed dx. So we're going to supply 4 here as a factor, then balance outside by 1/4. So finally, we now have what? So this is now read as 1/4 integral of a to the u du. So what is this, guys? This is u, not u. What about this? This is du, no? Not dme. Okay? So what's the answer? 1/4. Integral daw ng a to the u du is a to the u, a to the u over ln A, but what is our A? 2, and then plus C. Or if you want, you can express it as one term only in the denominator, meaning 4, I'm going to incorporate 2 to 2, no? So this can be written to the x to the 4 over these two factors for ln2 can just be ln 16, meaning ln2 to the 4th. Remember, 4 can be exponent of 2, right? You can have that if you want. Or of course, you can have 2 to the x to the 4 over 4 ln2. Okay, guys? Guys?
Yes po.
Okay, next, number 2. Oh, by the way, if you want, you can have simple U substitution. Let's say you want by simple U substitution. Simple U substitution. If you want simple U substitution, but it's nice about simple U substitutions that you can clearly see the formula, no? Because you will have really a to the u du form or e to the u du form, okay? So, given the integral of 2 to the x to the 4th, then x cubed dx. So again, our u here is what? X to the 4th, getting its du, that is 4 x cubed dx with our a equals 2. Now, we need to express this given in terms of what? U. So here we have to solve for du over 4. If we solve for du over 4, that gives us x cubed dx. So this part, I can express that in terms of du over 4. What about x to the 4th? So I can write that as u, no? So no more letter in terms of x. So everything now is in terms of u. So 2, then this is u. What is x cubed dx? That is du over 4. Okay, guys? So 1/4, I can put it out because I don't need that. So this is now in 1/4 integral of 2 to the u du. So what is the sound, children? If the sound is integral of a to the u du, a to the u du, what's the answer? The answer is a to the u, yan, a to the u over ln a, then plus c. Okay? But of course, u is not the original. So that is 1/4. Then ln o, I mean 2 times what? 2 times 2 to the u, but u is x to the 4th over ln2, no? Plus c. And then, that is equal to 2 to the x to the 4th over 4 ln2 or ln16. Did you understand why it is ln16, guys?
Yes po.
ln2 to the 4th, no? That is ln16. But of course, 4 ln2 is also accepted. You do not have to worry about that. Okay, let us have number 2. Integral of, let's say, e to the 5 tangent of x squared, then x secant squared x squared dx. What about this, guys? So let's try if the exponent of e is our possible u, no? So let's see. Let's take u equals 5 tangent x squared. Our a is e, so that is direct. We have a direct formula for that. Integral of e to the u du is equal to e to the u plus c. Again, what is e? Approximately 2.71828. That is an irrational number, Napierian-based. So, a here, I mean, what is du, guys? What is du? 5, then times what? Times derivative of x squared is 2x. Now, and tangent, that is secant squared of x squared. Okay? Then don't forget the dx because this is differential. Simplifying, that is 10 x secant squared x squared dx. Okay, guys? Let's apply simple U substitution. By simple U substitution, and simple U substitution, so meaning we're going to express everything in terms of U, no? So we now have, from here, what is x secant squared x squared dx? That is du over 10, right? Na?
Yes po.
So that is x secant squared, yeah, x squared dx. So the given now, I can express this in E. So 5 tangent x squared, that is U. Then x secant squared x squared dx, that is du over 10. Okay? So we don't need this 10 in the denominator. Put it out. So 1 over 10 integral of e to the u du. So this is exactly the formula now. What is the integral of e to the u du, children? That is e to the u, na? Still e to the u. Okay? Then plus c. But what is u, guys? So it is 5 tangent of x squared. Okay, very good. Yan. That's it. See, so you have already 3 formulas, aside from the general properties of indefinite integrals. Number 3, so integral of 5 pi to the sine squared 2x over numerator, dagdagan pa natin. Let's have sine 4x and then dx in the denominator. Let's say 5 raised to sine squared 2x. Or let's see if this is solvable because I just made it. Let's see if there's a solution for this. Okay, guys, let's check. Which do you think is the possible u? Or do we need to manipulate so that you can come up with a to the u form? Is it already in a to the u form, guys? Aljedi, Charles Dominic, Francis. Guys? Guys, Marcus, Andre. Boy, guys. Is it already in the a to the u form or do we still need to write? We still need to write, no? Notice that pi and 5 have the same what? Exponent, no? So I can write that as what? Integral of pi over 5 raised to what? The common exponent. Sine squared of 2x. All we need to verify if the remaining sine 4x is the differential of this exponent of pi over 5. So it means our u here, let's try sine squared of 2x. Our a is equal to pi over 5. Okay? So remember, our a is constant as long as not equal to 1 and then greater than 0, no? So what is du? Emmanuel Jordan, Emmanuel Rinaldo.
2 sine 4x po.
2,
Sine
2
4x.
times, drop muna, 2 times sine, then times
4,
2x times cosine of 2x then times derivative of 2x, 2, then dx. Why is it so? This is power, no? Drop the exponent, copy the base, that is sine 2x, get the derivative of sine 2x, cosine 2x. But the derivative of 2x is what? 2. Then dx because you want it to be du. Okay, guys? But what is this, children of the Philippines? From your trigo. Oh, what is this, children of the Philippines? Guys, that is what? Huh, guys? That is equal to, guys, equal to sine of 2 times 2x. So, and that is 4x. Remember, my angle theta here is 2x. This is 2 sine theta, cosine theta is sine 2 theta. But what is my theta? 2x. Okay? But there is still 2. So, 2 times, then dx. Okay, guys? So, which is now almost this differential. So, the integrand together with the dx, almost this what? This du, no? So, let's have correction factor. So, again, I'm going to apply correction factor. By correction factor, so meaning I'm going to correct the differential by multiplying it by 2. By correction factor, children, we have integral of pi over 5. You can use substitution if you want. Huh? Sine squared of 2x times, I'm going to multiply by what? By 4, by 2, I mean. And then balance outside by 1/2. So to compensate, no? Remember, ha? Only constant can be introduced in and out. Okay? Then times what? Times sine of copy, sine 4x dx. So how do we read this now, children? So this is what? This is u. What about this, guys? This is du. What about this? A. Integral of a to the u du. A to the u du. If the sound is integral of a to the u du, what is the answer, children? A to the u. A to the u. Over ln a. But what is my a? Pi over 5. Then plus your favorite C. That's already the answer. All we need to do is to put it in a nice form. So we have pi over 5 raised to sine squared of 2x over 2, then ln of pi over 5, then plus c. Understood, guys? Do you have any question with that? So identity is very important, no? We use that in this case. Because if you don't know how to apply identity, you're not able to recognize that sine 4x dx is possible to be the du of sine squared 2x, no? All we have to do is, of course, to supply what is missing, no? Yeah. Let's have number 4. Integral of e to the arc and arc secant of arc secant of square root of w, then dw over over square root of sorry. I mean W square root of W minus 1. I'm not really sure if I am having the correct problem. Let me see. Let's check. Let's see. Okay. So what is our U here, guys? Ha? Elwin Mark? Sino mga hindi mga pipi dito? Charles Dominic. Carl Andrew. Sumuko kay Sir Elpidio.
Sir, arc secant.
So arc secant of square root of W. I'm not really sure if this problem will really have solution. So let's just fix in case it will not have. So our A is E, so no problem with that anymore because we have a direct integration of integral of e to the u du, and that is e to the u plus c. Okay? What is its differential? What is the differential of this, guys? What is du, guys? Let's get first the derivative of this. What's the derivative of the square root? That is 1 over 2 square root of what? Of W, no? Yes. All over u. Diba u over u? Am I right? What is our u here? In arc secant? Square root of W. Right? Then square root of u. Its u is square root of W. So that is W. I mean square of this na? Minus 1. Actually, the differential, you have already the hint in the given. So you will able to recall, no? Okay na, guys? Then dw. Any question with that? How to simplify this, guys? When simplified, this is equal to this w here is multiplied to this w in the denominator and together with the 2. So 2 times square root of w, that is w. Am I correct, children? W minus 1. Okay, then dw. Alam nyo guys, para may nag-guide sa inyo, if in case in your family, there is someone in your family who is really good in math, you let them join, no? Para maturuan kayo pag meron kayong mga hindi maintindihan. Pag-join nyo. Okay, guys? So, this is du. Almost there, no? Except that there is a missing 2 in the denominator here to be this as du, na? So, let's have correction factor na lang, ha? So, again, by correction factor, we are going to correct the differential. Yan. Actually, this is not formal, no? You don't normally see this word in calculus books. But this is just made this term, correction factor, just to understand what we are doing, no? Yan. And let's call such by that name, no? So integral of, so this given now becomes what? What am I going to do? We have e to the u, but what is my u? Arc secant of square root of w. Okay? Chuapoco has left the meeting. Times, Alcantara also. Times what? What is potential du? dw, and dw over w square root of w minus 1. Then, what are we going to supply, children? we need to supply here 2, no? Which is in the denominator. Since it is in the denominator, where will I going to balance it? Numerator or denominator?
Numerator po.
Numerator, meaning multiply by 2 over 1 or 2. Okay? Naku, umakyat na naman ang pusa ako. Nanggugulo na naman itong muning-muning. Diyan ka lang, muning. Oh, so this is now read as, although it is color blue, but this is red. Not, although this is blue. This is read as 2 integral of e to the u du. Again, what is this, children? Oh, what is this? What is this? U. What about this, guys? Du. E to the u du. If the sound is e to the u du, what's the answer, children? E to the u. But what is my u? Arc secant of e square root of w. Then plus the beautiful c. That's it. Is that correct, children?